Hey everybody, it's Tyler here at Space City Signature, checking back in with an amazing team, 1095R, Run It Back. We talked to them last year. We're excited to showcase this year's robot and what they have here in high stakes. 1095R off to a great start so far with 3 comp wins already, Excellence Award, Skills Award. You just had a Triple Crown a couple days ago. Congratulations on that. 6th in the world in skills, around 16th in true skill. This team is a complete package here. Lots to talk about, especially from their strategy, how they're going in, some of their programming methodology. Talk about this huge chain they got going on, and a lot more great stuff. Come up here for Running Back on Pits and Parts. Bobby, let's talk about just some of the overall mat strategy that Run It Back is looking at implementing. I mean, the meta of this game is starting to change quite a bit as we go through. So talking about how you're approaching it so far, either both from skills or the match itself.
So with Auton being as important as it is, and top rings being worth 3 times the point value of regular rings, we have to maximize the number of top rings that we have at the end of the Auton period. And you can either do this by getting the wall stakes in Auton, which is soon going to become very, very popular, I think, or you could grab that 5th goal in Auton. And that's the one that we've opted for this robot because it also sets us up well for the driver-controlled period. So we've designed to this strategy with our rush mechanism here. This bumper here sort of just clamps onto it, and then if a team pulls on it, it'll just slip until it hits these standoffs here under there. So yeah, it'll just like clamp on the underside of that, and that's good. And then we pull it back, we can clamp on it with our back clamp, and then spread the 2 rings that we have over our goal and that goal. And so that is why we've implemented that rush mechanism.
When was that rush mechanism put on your robot?
So we first had it for Saratoga, but it was on our old robot, and it was different. It sort of went down and then passively came up. It didn't have like a clamp on it, so it sort of did this. It went under and then just came up like that, and then we pulled it back. But shout out to 1698V for making it not work by pushing on that. So then we were like, okay, we got to fix this. So now we have a top bumper. So hopefully they shouldn't be able to do that anymore.
Sometimes failure's the best teacher sometimes with that,
yes,
right? So
learn from your mistakes.
Yeah, I really like that though. And you know, from a match strategy, you mentioned wall stakes becoming more and more important, but getting that 5th goal is extremely important still for what we've seen. So I really do like the idea that is behind it, and obviously the implementation has been great for it as well. Sai, talk to me more about on your robot, some of the build process behind it. You're catting up your robot as well too, so I'd love to hear more about what goes into it.
So yeah, like Bobby mentioned, the first thing we did is we saw what strategy we want to implement. So the most important thing we did or kept in mind is we designed our robot to the strategy. So as you can see, we have the rush arm over here, but like all the small things such as the drivetrain speed, they matter a lot. So this is 450 RPM on 2.75-inch Omni wheels. So other drive speeds like 400 RPM on 3.25, which is really common. We saw that it's a really small drive base, which means your robot can be tippable. So we basically had a design matrix for every single mechanism, and the way we designed the robot is we had the hook system go first, the back clamp go first. So once we see where the relative position of the goal is, then you can design a conveyor belt or a hook system to score onto the goal. And then after you have your hook system catted up, then you can cat up a first stage over here. And then after that, we focus on wall stakes, and then we did the rush arm. So the most important thing we kept in mind as well while catting is making sure our build quality was as, I guess, to the max potential as possible. That way the robot performs consistently throughout all the matches.
And what program are you using for CAD?
Autodesk Inventor.
Okay, so with Autodesk Inventor, there's not much in regards to like cloud capabilities, right? Like, so when you're designing, are you able to still like work together or share, or are you doing the CAD yourself?
So that's actually a unique feature we have. So Bobby was able to set up our whole Inventor system on Google Drive. So I'm able to CAD the robot at home, and the second I'm done, I can click Control S. It'll save to the Google Drive cloud. Bobby can open it up on his PC at home, and he can CAD the rest of the robot if he wants to.
So you made your own custom repository, essentially. Basically,
yeah. So
right?
like,
that's cool.
We're able to like share the same parts and everything, and it's really fast as well.
No, that's really cool. I love that you thought that out too, right? So that's awesome. Let's pass it over to Rayon, by the way. Talk about the chain. You know, when we were talking earlier, I'm like, wait, what chain? And it's literally like the biggest thing on your robot that stands out. So talk to me more about why this chain's so important for your team.
Yeah, of course. So chain breakage is a very major thing in Vex, and the standard way to approach that is to double chain whatever component you want to reinforce. So for the front stage of the intake here, we were able to double chain it. As you can see, there's a chain here and a chain here. The same could not be done for the upper stage of our intake. And before we had like a vertical flex wheel intake, so this whole strategy didn't have to be done. But since we changed to a hook intake, the chain is basically on the backside of the tread itself, so you cannot double chain it in the same way as you would the front stage of the intake. So the way we went about this is we have a demo here, and essentially we zip tied each of the tread linkages, and you can see the backside as well. Each of the tread linkages are zip tied to the chain itself. And what this does is it not only doubly reinforces it, it triply reinforces the tread linkages. So it's able to stay secure and it doesn't have any problems with chain breaking. And we've tested this over like the course of a month in practice and whatever, and it has stayed secure, so it does work.
All right, I gotta ask you two questions on that. One, how long did it actually take you to do an entire chain with that?
I believe it was 8 hours, was it?
It took a while.
That's
Yeah.
quite the session. So,
A lot of
and
the
then you
time.
know you mentioned it hasn't broken yet, but if it does break, what's a replacement process look like for that?
Yeah, just redo it. I mean, I don't think there's really potential in it breaking, especially because we zip tied it like 3 times for each
Sure.
of them. So I don't think that's really something we've ever anticipated. Yeah.
Fair enough on that. Michael, let's talk about on programming on your robot here. We talked about earlier how important autonomous is to your team. Obviously, from your auto skills, you've been doing phenomenal from that as well too. So talk to me more about just what's gone in from a programming aspect on this robot.
Yeah, so to start, we have these two tracking wheels at the bottom, and what's interesting is that we use the 2-inch wheels, and to just account for like how the 2-inch wheel isn't a perfect circle, we have them doubled and offset. So these rollers are come in contact with the ground when these rollers don't, and we just do that by cutting the inserts of the 2-inch Omni wheels. And then also we have these all these joints for the tracking wheels are not canted, which really helps us just like keep our tracking consistent at all times, and that really helped us with the skills tracking. But sometimes, like after like 30 seconds or so, our tracking starts to get offset. So we use a distance sensor to hard reset. So what happens is, if we back up into the align stick, and this physical aligner will drive back and align us perfectly to the point that we will be. And using this distance sensor, we can see, oh, how far are we from the wall, and we can just reset our ODOM straight to that point. And that's really useful for just like when we mess up and we know we have that hard reset coming up, and we're like, yeah, it's gonna hit the rest of the skills. And then in addition, we have 2 optical sensors up here. So this first one is used for color sorting and to hold a ring. So right now I'm on the blue blue like program. So it'll just automatically shoot right out, and that's really useful just for like fail safes in auto and in driver as well. And that just helps like with consistency. And then in addition, something unique that we do, I think. Here, can you hold the ring? So we have this code called an anti-jam. So you can see right here, if I run the hook, it's gonna hit the ring perfectly where it just doesn't intake. So in auto, what happens is it detects the velocity of the intake is way lower than it should be, and then it'll just run outtake, and then it'll just re-intake again. So that's just also really useful just for preventing jams and stuff. And then in addition, we have this other optical sensor mounted at the top of our tank, and this one really helps us just keep this hook down. So what happens is when this hook is all the way up here, we cannot go under the bar, or else this hook is going to get slammed and break. So what happens is we use this optical sensor to sense the hook and keep it down right at the moment when we're crossing under the bar in skills. And this just really helps, because one time we got caught and it just like almost broke our chain where almost snapped off. And so this really helps us just like glide under the bar safely.
So teams, as you're listening to stuff like this, think about like this is what top tier teams think about and go through, and they test the processes and they go over it over and over again. And I think this really, for you guys, is run it back like why you've been so successful, because you are putting that thought process in, testing it out, and showing how it actually works. So teams, pay attention to that when you're testing your robots as well too. So run it back, thank you so much for telling us more about this year's machine. It's been great to check in with you all again. Wish you best of luck here at Space City. Can't wait to see more from you as well too. Good luck the rest of the way.